Welcome to this episode of UMBC's Mic'd Up. My name is Denise Cardona from the Office of Professional Programs. We're joined by Dr. John Johnson today, adjunct graduate faculty instructor with UMBC's Professional Engineering Graduate Programs. We hope you enjoy this episode. Thank you so much for joining us today, Dr. Johnson. We really appreciate you being here with us.
You're welcome. It's good to be here. Nice to meet you, Denise.
To start off, can you just tell us a little bit about the path that you took to land here at UMBC?
Wow. So the path I took to land at UMBC, I probably best could describe it as a zigzag path. I grew up professionally working in industry as an electrical engineer at first, and then a manufacturing engineer, then an industrial engineer, mostly in manufacturing environments at Motorola, AT&T, Corning Glass, places like that. And then I kind of zigzagged my way up the East Coast to Virginia, chasing remember the dot-com era when everybody was going to get rich with a dot-com company?
Oh, yes.
Yeah. So I came in just as the dot bombed. So I got in and enjoyed a nice run with a local high-speed digital access company. And then we were sold. And then I changed careers and did some consulting. And one thing led to another. I found my way starting at the bottom again I was a pretty senior executive vice president of operations and found myself as an engineer again, working in governments. That led me to start a business, but my business was always kind of, balanced with school. I've been in school forever, several graduate degrees. My wife, in fact, when I got my PhD, she outlawed school. You cannot go to school anymore. So
That's funny.
So then what else do you do if you can't go to school? Teach.
You teach, that's right.
Right. So that's kind of how I found myself teaching. That I always loved teaching. I might say it's kind of in our family history. My grandparents were teachers, my parents were teachers. So always loved teaching.
And it sounds like you have a wealth of experience to be able to bring to the classroom and to be able to teach students what you've been through and some of the lessons that you've learned throughout your career, your zigzagged career.
Yeah, I like to think so, and that's kind of my approach to teaching. By the way, I like to bring, anecdotes from my experience, but whether it's academically or professionally, and sometimes it's personally. It's being a graduate student and married with children and a business and life. Graduate school is hard, and so I can appreciate that when I can see students, under stress and trying but failing and needing some encouragement. I can relate to their situation. It's not all about making sure they understand how to do the math, so to speak.
Yeah, that work-life balance is an important element to grad students. It is a tough job to balance your work, your family, and your schoolwork. It's one of the challenges that most grad students deal with. So it's really nice to hear that you as an instructor are cognizant of that and empathetic of that. I think that's probably really special for the students. What courses do you teach?
So I teach two courses at UMBC. I teach the Quality Engineering and Management course. It's a engineering management course. And I also teach Risk and Decision Analysis, which is often listed under Systems Engineering. So SYST 672 for Decision and Risk, and ENMG 664 for Quality and Engineering Management.
Could you talk a little bit about what you enjoy most about teaching those specific courses?
So I enjoy different things about each of the courses that I teach. On the quality side, remember I mentioned that I grew up at Motorola professionally. So Motorola is the home of Six Sigma. This is one of the houses of quality, if you will, in industry and in manufacturing. So as a young engineer, this is how I was taught. I was taught quality, and it's kind of ingrained in everything I do, whether it's engineering or how I do work at home. Continuous improvement and managing variability. All of those things are kind of in my nature because of how I grew up professionally. So I enjoy bringing that kind of continuity from modern day quality history at Motorola to present day applications in information technology. I really like that element of it. And I like the risk and decision analysis, because quite frankly, this was one of the harder courses I had in grad school. And I feel really good. I don't like to say I've mastered the course, but I like that I've come from a point of being challenged by the course, and now that I can teach the course. So I know where students often struggle, because I struggled with it. And I can address those struggles from a point of experience. And it's also a very practical course. Math and statistics can be intimidating for people, and they often don't see the practical application for it. But risk and decision analysis is very practical to your everyday lives. In fact, we do a project every year, a real life project, and often those projects are not related to engineering and technology. One of my favorite ones was a student who did one on her wedding planning, and planning, all of the risk and decisions you might imagine that go along with planning a wedding, or buying a house, or selecting a car, or a snowblower. I mean, those same principles apply to technology. If I'm selecting a piece of equipment, or a manufacturing site, or an investment in or buying a business, so it's universally applicable across all really academic and professional domains. So I love that about that course.
Wow, that's fascinating, because it brings me to that point when I remember when I was younger and I was learning math, algebra specifically. And I asked my teacher at the time, well, how am I going to apply this in life?
Yeah.
And I remember her saying, unfortunately, I remember her saying, it doesn't really matter. You just have to get through the course.
Hmm.
And talk about demotivating a student.
Sure.
It would have been so great to know that when I got older and I went shopping, to be able to figure out what 30% off a shirt would be, I need
Mhm.
algebra to do that. So that would have
Yes.
been like a really great opportunity for a teacher to be able to show the practicality of what you're teaching.
Yes. Yeah. I got that from that approach. For me came same question, same class in algebra, but my teacher was Mrs. Parker, and Mrs. Parker was a character. And I have to say, a lot of my teaching style and what kind of motivates me about teaching is from Mrs. Parker in high school. And Mrs. Parker, when asked that question, she would talk about math as, she liked football. And she said, so, just like those boys go to the gym, and she talks like that, and they lift all of those weights and they get their muscles big and strong, math makes your brain big and strong, so doing those math problems makes your brain big and strong so you can think. And I don't know, that got to me.
Oh, I love
uh,
that. It's
yeah,
exercise for the brain. It
it's
always has
exercise
been,
for the brain, makes your
always will
brain,
be.
yeah.
That's great. So, what can students expect out of the classes that you teach?
Well, they can expect for sure practical application. This is like I said, I've been in graduate school a long time, had lots of classes, and the very best of those classes always walked away with something I could use. There are some cases in some classes where theory and just advancing knowledge and research is the point, and that's good too. The classes that I teach aren't those classes. The classes I teach and the way I approach them is very skill-based, meaning there will be some theory about why we do the things we do in quality and engineering management, or in risk and decision analysis, but we quickly move into how to do something. How do you perform an analysis? And then how do you use the analysis to ask good questions? Remember, we're training engineering managers and systems engineers. And from my experience, a good engineering manager asks good questions, recognizes when what's being presented has risk associated with it. And then even if you are not the subject matter expert, you should be able to apply good quantitative analysis and good sound, robust evaluations to situations, and either formulate a good question or defend your own proposal. So students walk away with I think, really good skill sets to ask strong questions and defend good decisions.
Yeah, finding those really solid solutions depends greatly on being able to ask those really great, important questions to get to the
Yes,
root of it.
yes, exactly.
Can you talk about student engagement in the classes that you teach?
So student engagement in the classes that I teach is really, I mean, that's part of the fun of the job. The students make the class fun for me. If you ask some of them, you'll find the begging for feedback. So what do you guys think? So what is it? Tell me something. So I need the feedback as fuel for me in the class. So it comes in the form of conversation and interaction with students during lectures. And then there's engagement with students outside of class in the form of help, assistance, support. Sometimes not everybody's going to ask the question in class, and they need the safety of a one-on-one conversation to ask it, not be concerned about how it's going to sound, not even know exactly how to ask the question, but just to say, I'm not quite getting this. And you don't want to say that in a classroom where, the A personality person is raising a hand all the time and they're giving all the answers. And then you say, I don't get it. Not everybody has that type of approach to their learning. So outside of class, I I enjoyed the one-on-one interactions with students. I'm an early guy, as we talked about setting this up. So, if they're willing to get up early or they're willing to, hang out on a Saturday morning, I'm good with scheduling a meeting, and we can talk as long and as deep as you want to about any of the topics. So I enjoyed that part of the interaction as well.
Wow, that's really fantastic for students to know that you are so engaged in their learning. That's pivotal for a lot of people.
Mm. It was pivotal for me. I experienced that when the light bulb went off for me in cases because I had instructors who invested in my learning, and sometimes one guy in particular, Jose Padilla, is a good example of a guy who was not officially my teacher in a class, but he invested in my academic training to help me advance, to help me with my research. And he didn't ask for anything. He didn't get paid to do it per se. Um, he did it because I was willing to invest, and he knew I wanted to learn, and he wanted to teach, and so it was a good marriage, and that's kind of how I feel is my it's an opportunity to do that. At least not every student is interested in going deeper, and that's okay too. But some students really want to get it, and if they do, I'm willing to invest if they're willing to invest. So
Sometimes students just want to know that they have somebody there encouraging them and supporting
mhm,
their actions and their journey
yeah,
towards education.
yeah, and telling them they can do it because sometimes you're not sure.
That's right. Yeah, absolutely. How does the class prepare students for success?
Well, the class prepares students for success, kind of beyond the technical or academic components. We could talk about that. But I think it prepares them for success in some maybe broader or more intangible ways by putting them in a situation where they're having to acquire new knowledge. And professionally, that's been my experience. No matter what you learn at school, you're always going to find yourself in some situation where you don't know what you need to know. And so you're going to have the skills for how do I acquire that knowledge? I have to ask people. I might have to read. I might have to research. I might have to trial and error. There are different ways. And so in this class, students are kind of put in a position. Usually it's new to them. Not many times do I encounter a student who is already familiar with decision and risk analysis and Bayes' theorem and conditional probability. They know a little bit, but they don't know it the way it's getting ready to come at them in this class. And they maybe knew a little bit about quality, but they're not quite sure about, Six Sigma and Lean Six Sigma and, how to reduce variation and all of these things are new concepts in most cases. And so they're having to dig, and I give them the opportunity to dig. It's very challenging. My best classes, what I try to do is to take the best of the best classes I've had and try to incorporate those things and try to correct the things I thought were the worst in the worst classes. And so I want to make sure it's challenging. I want to push them beyond what they think they can do. And then I want to give them a path for success. And so that's a lesson in learning. So if you get used to doing that, then after this class, you'll encounter it again. You'll have another class or another life situation where you don't think you can do it. It's very hard. It's very difficult. You'll keep working at it. You'll find a path to success. It'll be good. And then so you'll know, hey, I did it before. I can do it again.
Ah, that's great. I love that. That's so powerful. Can you talk about the nature of the engineering field, sort of in general, and why it's important to the world and to organizations?
So the engineering field at large is important to the world because engineers, it sounds cliche, but engineers solve problems. That's why engineers really are in place in our society, is to solve problems, whether it's, how to move people from point A to point B, or how to move information from point A to point B, or how to make a decision about which alternative to select, or how to make something better, less expensive, more effective. Those are all problems that engineers get to solve. And I think preparing engineers to have the skills to solve problems, and then I'll say the soft skills to ask good questions. I shouldn't call them soft skills because there's some really tangible skills to formulating and asking strong questions. Pairing engineers with those skill sets make them more effective problem solvers. Engineers' contribution to society is we solve problems. That's what we do. And we solve them in a variety of domains and capacities, whether we're solving them as managers, engineering managers, or we're solving them as technicians, figuring out technology, or we're solving them even in social constructs, how to organize people in a way to accomplish a goal. Those are all problem solving activities that engineers address in our society.
How can a student get the most out of your class? Like, what should they be going into this class or classes with so that they can get the most out of it?
So students, in order to get the most out of the classes that I teach, in fact, in my syllabus, I give a list of success factors. These are things that you want to do. You want to be successful in this class. So you want to read the material, and you want to try every problem. You don't have to successfully complete it, but you want to try everything. And the homework, trying the problems, and the reading, all are preparations to put you in a position to ask questions. Come to class and ask questions. If you read, you practice the problems, and you ask questions, those students I find are very successful in the course. If you shy away from the reading, you don't really have a foundation for asking a good question. If you don't try the problems and fail, I really like it when students try problems and fail, because that usually leads to the best question. If you don't try it and fail, then again, you don't have the basis for a good question. So a failure followed by a question is the best route to success, in my opinion. In that experience, if you do those things, you'll be successful in the course. I give lots of opportunities to be successful, but you got to put the work in.
What excites you most about being in this field?
What I like best about being in this field, technically, is that it's changing. It's constantly in motion. Since I can't go back to grad school anymore, so I get to learn, in my field. For example, I'm currently involved in learning some more about cybersecurity as I move my business. We're working toward certifying our business in one of the cybersecurity domains. Well, I'm not a cybersecurity expert, so I'm having to learn about that technology. And as I learn more about it, I'm able to apply it in other areas of our operation. So I like that it's changing and it's dynamic. What I like about the teaching environment is that I get to share that with students. And maybe the best thing I like about the teaching part is I get to see when someone has had a great experience in the class and it's led to a great experience outside of the class. I think when I've had one of, in several cases, students I saw working really hard in class, and they go off to an internship or to a job, and they'll write back and they'll say, Professor, I'm working on this Six Sigma project, and my manager told me that I'm applying this better than anybody he's ever seen do it before. And when they're excited about what they've learned and they've applied it somewhere, that's golden. That's what's the MasterCard question? Commercial, one of those say that's priceless. um, that's what I probably enjoy best about this.
Oh, yeah, it's priceless, right? That's perfect. It's golden.
Golden, yeah.
Can you talk a little bit about your business? Because you've mentioned it a few times, and I think that would be really interesting for students to understand what you do in the field and what you bring to the class from that
Sure,
experience.
sure. So my business is systems thinking and solutions. So I started that after my corporate career, moving around in manufacturing and supply chain operations, quality assurance, and just a variety of eclectic jobs in corporate America. I started a business, Systems Thinking and Solutions, and we are an IT services and professional services company. Basically, what we do is for primarily for government agencies. We provide the information technology support to allow enterprise software and applications, the infrastructure of an operation to work. We also provide the technical support to acquire information technology. So we like to say to acquire, maintain, and improve information technology. Those are the kind of the things that we do. So we have a list of capabilities that kind of relate often to these classes. The continuous process improvement is Six Sigma work that ties directly to the quality and engineering management course. And then a lot of the things around enterprise architecture and technical support for enterprise software have to do with decisions that have to be made in an enterprise, which relates directly to risk and decision analysis. So that's what we do.
That it really does relate nicely to what you're teaching in the class. So the students are gaining this firsthand knowledge from you, from somebody who's actually in the trenches, doing the work and rolling up their sleeves and getting the work done.
Yes, absolutely. In fact, it was just yesterday in class. We were discussing a decision and risk situation, and I gave them an example of a real life model. We're building a simulation model, and I was able to use that example that I was fresh out of a meeting on the day before. We used that example in the class on Wednesday. So yeah, I think that's one of the values of having adjunct teachers in the program, is that they're bringing real life experience, current experience to the classroom.
So you've talked a little bit about failure, right? And how it leads to great questions and to ultimate success, really, in a project. Could you give an example of a failure that maybe you went through in your career that has shaped the way you teach?
Interesting. Well, let's see. I'll give you a good one. When I was working, and there have been many, that's why I hesitate. So, I guess I'm proud to say I've had many failures. This is true. Academically, one failure was around, let's say, priority and focus or preparation. When I was in my PhD program, I got distracted at some point, and that distraction with life and everything else, I didn't put the focus on finishing a dissertation that actually led to an additional year in the program for me. So imagine the heartache when I get a call from a classmate who's, "John, I just walked across the stage. I'm looking for you. Where are you?" "I'm not there, buddy," because I didn't graduate. know? But that failure gave me a renewed sense of focus. And that renewed sense of focus, I dug deeper. And I think my dissertation and subsequent papers that I wrote, and eventually some published in journals, were better because I spent that additional year at a level of focus that was unparalleled to what I had done before. So by failing, which I can't say I would do it again, but that failure led to a level of intense focus that led to better products for me academically.
It's a powerful story right there. Most of us don't view failure as a positive stepping stone, if you will, whereas through your experience, it proves that failure can be a positive stepping stone to greater success down the road.
Yes, absolutely. And Another example of failure for me would be this class that I'm teaching, risk and decision analysis. I ultimately got a good grade in that course, but when I took it in grad school, the first part of that semester, I was failing that course. I couldn't understand it. The professor was teaching and he was speaking Greek as far as I was concerned, and I just couldn't get it. I didn't understand it. And I remember getting a book, Statistics for Dummies. And I had a friend, I had a classmate who encouraged me and said, John, you can do it. Get this book. And again, got a renewed sense of focus. And I read more. What I realized, you need to read more. You need to read this book more. You need to read it. For me, I needed to read it 3 times. For someone else, they got away with reading it once. But what I kind of came to grips with is you need to do the things you need to do for you so that you get it. And that's what I encourage students. If it takes 1 time reading and you get it, great, good for you. But if it takes 2, 3, 4 times, then that's what you have to do. And that's what I did. So I dug in deeper and I read more, which is why and I tried the problems and failed at the problems and came to class with different questions. So different questions, different level of reading. Eventually I started to get the concepts. Once I got the concepts, then I could learn on my own because I had the foundations. And so that taught me 2 things. Teach students concepts. I think what my professor didn't do as well as I'm trying to do is to give the foundation of concepts so that it helps students on their self-learning path, and then to encourage the questions and failure so that you try, you fail, you ask, you learn. And that's what I got. And in fact, he uses my project from that class as his example. I went from the bottom student to the example student in that class. Because I knew I could do that, my experience, I encourage other students, just because you're failing now doesn't mean that's where you'll end. Go to work, read more, practice more, ask more questions. And when they do, they succeed.
That's proof of concept right there. Nice role model for people to be able to say, yeah, if I can do it, you can do it. It's that mantra of, if I can do this, I can do anything.
Yeah, exactly. Once you've had that experience, the next experience that sounds similar, hey, it feels like I can't do it. You say, I recognize this. I felt like that before. What did I do? I dug deeper. I did more. I worked harder. And I succeeded.
I am going to be thinking about this whole failure thing in such a different way because I tend to be kind of a perfectionist. And I think that's it's a limiting place to come from when you're trying to get to the next level.
There was a class, it just made me think about a class I took when I was at Motorola. And this class was about I can't think of the name of the class. Maybe it's an efficacy class or something, self-efficacy. I don't know what it was. But in any case, there was an exercise. And the exercise was you would try to get points by tossing a ball into a bucket. If you stood at the 5-foot line or 1 foot 5 line, 3 foot line, 5 foot line, 10 foot line, right? You stood at the 10-foot line, you could get 100 points if you got it in the bucket. If you stood at the 1 foot line, you only got 1 point. And you can imagine as the further you got, the more points, right? So make a long story short, where do you stand to maximize your points, your wins, right? And what the experiment showed was that people who stood too far away from the bucket, trying to score the max points every time, tended to lose. The people who played it too safe, standing at the 1 foot line and only getting 1 point at a time, 100% success, but very small victories, they lost. The people who tended to win the game were people who stood a little further back, had some failures, but a few successes, learned from successes, and got more points. And so the moral of that story was, if you're hitting a bullseye, then you're too close to the target. That's what we took away from that training. And so you need to stand further back so that you don't always hit a bullseye, but that you learn from missing it and you get better each time. And that's the whole failure and learning concept.
Wow, that's so cool. That's such a great analogy, such a great way to view that. That's actually a very strong analogy. So it's something that I will be able to remember when I am thinking back on this conversation, is that whole bullseye. If you're too close, you keep getting those bullseyes, you're too close and
Every time.
you're not challenging yourself enough.
There you go. Exactly.
So this brings us to the last question. Is there anything else that maybe I didn't ask you that you think would be of value to this conversation that I might have left out?
Denise, I can't think of anything you haven't asked me or something that I would add. This has been an interesting conversation. I've enjoyed chatting with you. You made me think about a few things, particularly that question around failure. I'm not sure what I would say next time. I have to think about that some more. So good job as a journalist there, pulling that out of me.
That's great. Thank you so much, Dr. Johnson, for being here. It's been such a pleasure talking with you. You've expanded my mind when it comes to this whole failure concept, and you're really going to have me thinking very differently through it. So thank you for that.
You're very welcome. You're very welcome. Have a great day, and tell everybody to fail up because it'll lead to success.
Thank you for taking the time to listen to this episode of UMBC's Mic'd Up. We hope you enjoyed it. If you'd like to learn more about the professional engineering graduate programs at UMBC, please visit us at professionalprograms.umbc.edu.